Question 1. Okay, this question is about organic chemistry, which use a greenness reagent for the reaction. And the general formula for this greenness reagent is RMgX. R is a hydrocarbon, the X is a halogen. In this question, the greenness reagent, the R group is the benzene, and the X is bromine. And this reagent is used to prepare the alcohol. In this question, is used to form the 1-phenyl ethanol, and the greenness reagent will react with the ethana to produce this alcohol. And there is an organic solvent used during the reaction, which is the epoxyethane. And there are 3 equations here, which to make you more familiar with the reaction. The first reaction is magnesiums with the bromobenzene. So this is the reactions to produce the greenness reagent. And once the reagents produced, then this greenness reagent will react with the ethana to produce the intermediate, and this intermediate further reacts with the acid or the hydrogen ion to form the alcohol. At the same time, this magnesium and the bromide, so they will form the other salt. Okay. Now, in order to make you understand better, so I briefly described the mechanism. Okay, how the step 1, step 2, step 3 happen. Okay, the first one is to produce the greenness reagent. So magnesium will react with the bromobenzene. So basically, it's like first the CBr bonds break homolytically. Then the bromine radical will react with this magnesium to form this intermediate. So the magnesium use one of these electrons to form a bond with the bromine. Okay, after that, this benzene, so it will form another bond with the magnesium, right? So that's how these reagents produced. Okay, this is for step 1. Okay, now these reagents it will attack this ethana, because in the question is mentioned ethana. So this bond, okay, there is a pair of electrons, the C and the magnesium. So this is a nucleophilic attack. So it will this pair of electrons will attack this the carbonyl-carbon, and the pi bonds break. So eventually it will form this intermediate, right? So this intermediate, and this oxide, it will use one pair of electrons to get the protons, and eventually the magnesiums and the bromides will form the other salt, right? So means when oxygens now it gets this proton, so it will form this OH group, means it will form this 1-phenyl ethanol. So this is the step 1, 2, 3, how do the reactions happen. Okay, let's start from the step 1. We go through one by one. Okay, for step 1, set up the apparatus shown in the figure 1.1, and with about 1.25 grams of magnesium powder and 5 cm cube of epoxyethane in the round bottom flask. Okay, so this is the first step. So means just put the magnesium powder in the organic solvent. Then second step, so this second step is to prepare the reagent. Add 0.05 moles of liquid this bromobenzene to the round bottom flask. Okay, and leave until the reaction once complete, means to form the greenness reagent. And it add drop wise using what? Using the tap funnel here. So means this is the Okay, initially this is a magnesium with the epoxyethene, the solvent. So for the step 2, wish to produce the Gridson reagent. So 0.05 moles if you get into the flask through this tap funnel. Okay, then let the reactions happen, form the reagent. Okay, then next step. Okay, once the reaction 1 means the Grignard's reagent produced, then step 3, dissolve 3 cm³ of the ethana in the same organic solvent, epoxyethane, and add the solutions to the round bottom flask. Use the tap funnel also. Okay, leave until reaction 2 is complete. So now is the reagent, the Grignard's reagent react with the ethana, which to produce the intermediate I told you just now. Okay, this intermediate. Okay, so once the reactions 2 complete, then it's time for it to react with acid and form the alcohol. Alright, okay, so now for step 4, remove the condenser, tube Y and the tap funnel from the round bottom flask, means all detached. All this one removed, and we need these round bottom flask only according to this step 4. After that, add 40 cm³ of the dilute HCl to this round bottom flask. Then eventually the alcohol will produce, means the intermediates will react with the acid to form this 1-phenyl ethanol. And of course the magnesium and the bromine, they will form the ions or the salt. Okay, that's how the reactions happen. And after that, after the alcohol are being produced, then transfer all the mixture, reaction mixture, to the separating funnel. Okay, so you have to understand. First is start with the organic solvent, epoxyethane. Then in step 5, the aqueous solution added, the acid. So means now the organic layer and the aqueous layer, they are invisible. So we need to use things called separating funnel to separate them. So transfer this all the mixture, the aqueous and organics layers, to this separating funnel. Allow the liquids to settle. Then we need to do the separation. Separate the 2 layers. Okay, open the tap of the separating funnel. Run the lower layer to the pickle labeled A. So the lower layer is the one that higher density. If we compare the density of the water and epoxyethane, so from this table, epoxyethane, the density is 0.714. Water is 1. So means the lower layer, it must be aqueous layer. And the upper layer is the epoxyethane, the organic solvent. So now, okay, let's get back to this one. So because now is mentioned the lower layer and the upper layer. Okay, so again, the lower layer must be the aqueous layer. Okay, now this aqueous layer get into the bigger A, and then the upper layer it will get into the this pickle B. So upper layer means the epoxyethane, the layer. Okay, after that, allow the epoxyethane to evaporate from the pickle. This one obviously is pickle B, right? And which contains this alcohol, the 1-phenyl ethanol. Okay, so I hope you all understand, right? The whole process. Then it's easier for you to do the to answer the questions later, right? Okay, now let's start. Okay, this table, the density we already discussed, and we'll get back to this one again later. Okay, for A, use the information in the table 1.1. Suggest why the following safety precautions are used. First, wearing chemical resistant glove, means chemically resistant glove is for the corrosive chemicals. So then you just find the corrosive or the skin irritant, means for the bromobenzene. Okay, so this is the reason, okay, why we need to wear the chemically resistant glove, because bromobenzene is a skin irritant, right? Okay, easy. Second precaution is use fume hood. Whenever use fume hood, you just remember it might involve toxic gas. Whenever the toxic gas used in the reaction or produced from the reaction, it's better for us to do it, means conduct the experiment in the fume hood, because fume hood there is a suction, so it will suck out all the gas from the reaction, so we will not get affected. So then here you just put those compound that is toxic, that involve toxic gas. So means for the bromobenzene and this ethoxyethane and one phenylethanol. So because toxic compounds such as bromobenzene, ethoxyethane and one phenylethanol, they are being used, okay, and produced. Of course, the one phenylethanol is the one that being produced. Okay, part B. Dry apparatus and the reagents are essential in the step 1 to 3. Suggest how the glassware shown in the figure 1.1 means all these round bottom flask, condenser, all this tube. How this one being dry? That's the question. It's here. Should be dry before use in step 1. Okay, we just dry the glassware in the oven, something like this one, oven. Because oven we can control temperature. Normally we'll control higher temperature like between 70 to 80 degrees C, and because in the oven there is airflow, so we can use some hot air or the airflow to make the drying process faster. Okay, so means in lab when we want to dry something like glassware, to make it fast we will use this oven. Don't use furnace. A furnace is used to burn things. Is oven. Okay, so for part 2, the ethoxyethane contains a small amount of water. So suggest how water can be removed from ethoxyethane before use in step 1. So because the ethoxyethane, the boiling point is different from water, so it's lower. Ethoxyethane boiling point is quite low, 35. Water is 100. So we can easily separate these two using the fractional distillation. So the ethoxyethane will be the one that collect first. Okay, so this is the one. Whenever the compound they have a different boiling point, so we can use this techniques to separate them. Okay, part C. Figure 1.1 show the apparatus for the step 1 to 3. Draw a label arrow on this figure 1.1 to show where the water enters the condenser. So water must get into the condenser from this lower part. Why? Because when the water get into from this lower part, okay, so means the water will fill up the condenser slowly until this condenser is fully filled, okay, by water. Of course, the inner tube it has no water, right? So it's just the outer tube full with water. Okay, then the water out will be this upper part. So by doing this, then the water it will always full in this condenser, the outer tube in the condenser. That's how you draw this arrow. Water in, water out. Okay, part 2. Suggest why a solid Z is used. A solid Z is what in this diagram? Solid Z. Because this is an organic reaction, it might be this water sensitive. So the solid Z is water absorbance. Is used to absorb the moisture, prevent the moisture enter the setup. So that's why we put this solid Z in the tube Y. Okay, so to prevent the water getting the moisture get into the apparatus. Okay, part 3. Give one reason why the apparatus does not have a bunk at the end of the tube Y. Why there is no bunk or stopper. So because you need to let this open. For this reaction, we need to warm or heat the mixture. Or during reaction, it might form some gases or what. So it's better we let this setup open. If you put a bunk here, then if the pressure build up, then it's quite dangerous. So we just try not to let the pressure build up. That's the reason. So to prevent pressure build up in the apparatus. Okay, part D. In step 1, about 1.25 gram of magnesium powder use or is needed. Okay, outline how student could accurately weigh by difference using a weighing board. Is a small plastic container, so that exact mass of the magnesium transfer into the flask. Include the results table, which appropriate headings, and ready for the student to fill in. Okay, this one is quite straightforward and it's quite easy. What we need to do is we need to get two mass. So we need to get the mass of the weighing board with magnesium before transfer, and weigh the mass of the board with residue after transfer. So we need to get these two mass. Okay, we can therefore calculate or get the actual mass of magnesium get into the round bottom flask. Okay, so this is what we need to do, and we put the correct item into the table. Okay, so the mass of the weighing board plus the magnesium before transfer. Second is the mass of weighing board plus the magnesium residue after transfer. So you use the before transfer means the first one minus the second one, you get the actual mass of magnesium powder that transfer into the flask. Okay, unit is of course gram. Okay, part E. Use the information in table 1.1 to determine the volume in cm cube of the bromobenzene used in step 2. Because in step 2, the bromobenzene is 0.05. If I follow this step 2, 0.05 moles of the bromobenzene used. Then we need to use this mole for the calculation. So 0.05 moles, then times its molar mass given in the question, 156.9, then you will get 7.845 gram. So the volume of this bromobenzene, so you need to use the density. This one is given in the table, so you just use the density of the bromobenzene. So eventually use the mass that calculated just now over the density. So you get 5.23 cm cube. That's the volume of the bromobenzene used in the step 2. Okay, part F. The bromobenzene is added dropwise in step 2. Suggest one reason why bromobenzene is not added all at once. It is quite general. Normally we will not add all together or at once because sometimes reactions might be too vigorous. So to prevent the reactions becoming too violent or vigorous. Okay, part G. Suggest why a measuring cylinder is a suitable piece of apparatus to measure the 40 cm cube of HCl. In step 5, this acid is just used to produce the alcohol, and is in excess. So when the reagent is in the use is in excess, it's not really that particular. We must use a pipette or burette. So we can just use the measuring cylinder to get roughly about 40 cm cube. That's enough. When it's volumes that used for the preparations, for example, for a solution, then it's another story. Okay, because this one, the HCl is already in excess, so it doesn't matter we use the measuring cylinder. Okay, for part H, this is a separating funnel. So in this separating funnel, now it has two layers from the round bottom flask. The upper layer is the one that lower density, which is the epoxy-ethane layer, the organic solvent, and lower layer is the aqueous layer. So this is the one that we discussed in the step 6 and 7. Okay, so means because already say the final products 1-phenyl ethanol is in epoxy-ethane layer. So now we can know that this alcohol is in the upper layer. So state whether pickle A or pickle B contains the layer with 1-phenyl ethanol. Okay. A is the aqueous layer, B is this upper layer, the organic layer. So of course it's pickle B lah. Okay, so explanation, because epoxy-ethane is less dense than water. Okay, this is 0.714 you can get from the table, and this is 1 gram per cm cube. So that's why we have two different layer and different density. Okay, part I. The overall reactions can be represented as shown in this figure 1.3. At the end of step 8, okay, 2.17 gram of 1-phenyl ethanol is obtained. This is a product. Determines whether bromobenzene or ethanol is a limiting agent. So means which reactant now is a limiting agent, and therefore calculates the percentage yield of the 1-phenyl ethanol. In order to do this, then you need to at least get the mass, and after that get the mole. From this equation, all the reactants they are actually in 1:1 mole ratio. Okay, so let's check the moles that being used. Okay, because it's asking which one is limiting agent, bromobenzene or ethanol. So we focus on these two. The bromobenzene, this one already given in step 2, so we no need to do further. 0.0500 mole. Okay, and now we need to get the mole of the ethanol. Ethanol, the one that used in the reaction is 3 mil. 3 cm cube. And the 3 cm cube, we need to use the density. Let's check from the table. You can get all this information from the table just now. Okay, from here. The ethanol density is 0.788 gram per mole. So means you just use the volume times this density, you get the gram. Okay, means to get the mass of the ethanol, you use the volume used in the reaction times the density. So you get 2.364 gram. Okay, once you get the gram, use this gram over the molar mass of ethanol, so you will get 0.0537. Okay, so now let's compare the mole of the ethanol and the bromobenzene. Okay, so the bromobenzene is lesser mole, means we know that these bromobenzene will form lesser products because they are all in 1:1 mole ratio, isn't it? 1 mole of bromobenzene will form 1 mole of this alcohol, and 1 mole of ethanol also will form the same mole, right? So again, from here, because the moles of the bromobenzene is lesser, we know that it will form lesser products, lesser amount of 1-phenyl ethanol. So means the bromobenzene is a limiting agent. Okay, once we identify limiting agent, then we must use the mole of the limiting agent for the most of the products. So 0.05 moles of the bromo benzene will form 0.05 mole of this alcohol. Okay, so use this mole times the molar mass of the 1-phenyl ethanol, the products, you get 6.1 gram, 10 gram. Okay, so because the question asks what is the percentage yield of the product, and this is actual yield. Actual yield that get from the experiment is 2.17. To get the percentage yield, we use actual over the theoretical times 100%. So the actual is 2.17, theoretical is 6.1, which calculated just now, and times 100%, you get 35.6%. Right, so this is a percentage yield. Part 2, suggest why infrared spectrum of the product detected the presence of this carbonyl group. Quite easy, because in the reactants only ethana has carbonyl group. So that's why this is the answer. The product, okay, because it contains unreacted ethana, that's why the IR will give this peak. Okay, that's all. Thank you.